students, myself Dr. Shreya Mehta. I am taking your Elements of Mechanical Engineering subject, and in the today's lecture we are going to discuss about the refrigeration and air conditioning systems. In the earlier lecture we have already discussed about how refrigerators are working, what are the basic principle, what is the basic principle, what are the different methods of producing the refrigeration, unit of refrigeration, vapor compression refrigeration system, and what are the different components of vapor compression refrigeration system. In today's lecture we are going to learn about the first introduction, then some portion, thing we will discuss about the refrigerants, then vapor compression refrigeration system. In the earlier lecture what we have discussed, the advantages and disadvantages of vapor compression refrigeration system, then vapor absorption refrigeration system, air refrigeration system, air conditioning. In the air conditioning, window air conditioner and split air conditioner, we will compare the window air conditioner and split air conditioner. So let's start with the refrigerant. Now what is refrigerant? So in the last lecture also we have somewhat discussed about the refrigerants, that is, it is a working medium used in the refrigeration system for producing the refrigeration. It actually absorbs the heat at a lower temperature and pressure by evaporation. That means it absorbs the heat and get evaporated and rejects the heat in the condenser, that is one of the component of vapor compression refrigeration system. So whatever the heat it has absorbed in the evaporator and it has got evaporated, that is rejected in the another component of refrigeration system, that is condenser. So rejecting the heat by condensing at a higher temperature and pressure. So refrigerant is a working medium used in the refrigeration system for absorbing the heat and same heat to reject it at another component. Now how we can choose the different refrigerant, that is what are the ideal refrigerant, what is the gas, which are the gases that should be used for the refrigeration system for producing the refrigeration or cooling. So how we can choose? So what are the desirable properties of refrigerant? That is, let's first discuss about the desirable properties of a refrigerant, that is thermodynamic property. If we see, then it should have a high latent heat of evaporation so that more amount of heat it can absorb, good thermal conductivity so that it can absorb. There should be a good heat transfer between the medium and the refrigerant, then high critical pressure, low saturation pressure. So these are the different desirable properties of a refrigerant. Other than these desirable properties, we can say that it should not be harmful if it leaks from the system to the person. So it should not be harmful to the human being, that is, it should not have any harmful effect. It should not be toxic. Then it should be available easily in the market. Then it should not be costly. Then it should not react with the components of it should not react with the material of a components which are used for the refrigeration system. As for example, refrigerant is passing from the condenser. So condenser is made up of tube and fins. So condenser tubes are of a copper. So refrigerant should not react with the copper. So material refrigerant should not react at a high temperature and pressure with the material of the component. So these are other than the thermodynamic properties, that is, it should not be harmful, it should not react with the material of the components, then it is easily available it should be easily available in the market, and should not be very costly, and finally it should have a odor actually. Then if it leaks, then if one can immediately realize, then there is some leakage. So it is having some odor, so that we can prevent the leakage and prevent the other component to get destroyed. Then selection of refrigerant. So it is based on several factors. Performance, so it should have a desirable thermodynamic properties that we have seen, and that show that adequate cooling can be achieved cost effectively. Safety, avoids the hazard, so it should not be very toxic. Environmental impact, yes, it should minimize the harm to stratospheric ozone layer and reduces the negative impact to the global climate change. What does it mean? It means that it should not react with the ozone layer which is in the presence of sunlight. Like halide group of refrigerants are having an excellent thermodynamic property, but the main disadvantage of halide group of refrigerants are that it is reacting with the ozone layer. So if it gets reacted with the ozone layer, there will be a hole in the ozone layer, and directly the sunlight can come on the earth. So ultraviolet rays, due to that UV rays, that global warming occurs. So it should minimizes the harm to the stratospheric ozone layer and reduces the negative impact to the global climate change. So here in this table you can see that as I have told you that R12, R22 is having a halide group of refrigerant, these both the refrigerants are having excellent thermodynamic property, but you can see the ozone layer global warming potential is highest, so that they are replaced with the refrigerant like 134A. 134A, I will say here that 134A is not an ideal refrigerant. Here generally used in the place of R12 or an R22. It is having a lower global warming potential, but it is not yet ideal refrigerant. So why then it is used nowadays? But so I would like to mention over here that the system which is designed and which was working with the R12 and R22 refrigerant, which are refrigerants are now banned due to the ozone layer depletion. So that's why if we want to retrofit, that is for the same system, if we want to use any other refrigerant other than R12 and R22, then one should use the R134A. That is, it can be easily charged in the system which is designed for R12 and R22. So that's why R134 is retrofitted in the system which is already used for designed for the halide group of refrigerants, and it is having a good other thermodynamic properties, so it can be used. But as I have told you, it is not yet an ideal refrigerant. So these are the different refrigerant. Ammonia, and ammonia is also having a good thermodynamic properties, but it is very toxic, and leakage of ammonia causes a harmful effect. So these are the advantages and disadvantages, and we have to optimize and we have to look at the application, particularly for which application we are going to use the refrigerants. So accordingly the refrigerants are selected for the refrigeration system as a working medium. So this we have talked about the different types of refrigerant which is a working medium used for the refrigeration system. And now we will compare the vapor compression refrigeration system, which we have already learned in very much detail in the earlier lecture, with the vapor absorption refrigeration system. So what are the different advantages and disadvantages of a vapor compression refrigeration system? Why we have to switch on, or why one should go for or one should look for another system that will produce the cooling, that is vapor absorption refrigeration system. So in today's lecture we are going to learn in detail about the vapor absorption refrigeration system, and so that's why we are going to learn about what are the disadvantages of vapor compression refrigeration system, that we will see. So why vapor absorption refrigeration system? The major drawback of vapor compression refrigeration system is large volume of refrigerant vapor which requires to be compressed, in turn which requires the large amount of mechanical power for operation. If this volume is reduced before the compression, and then there would be a considerable reduction in weight of the system and power requirement for the operation. And another main advantage of we can say for the vapor absorption refrigeration system is any other type of heat energy which is readily available, that is exhaust steam from the turbine or some exhaust gases from the gas turbine plant. If that kind of heat energy is available, so we can readily use that heat energy for producing the refrigeration. So that is the advantage of vapor absorption refrigeration system, and it gives the high COP of the system with a machine operated with the supply of this kind of heat energy. So advantage of vapor absorption refrigeration system. So there is no moving part, as the compressor of vapor compression refrigeration system is replaced here in the vapor absorption refrigeration system. So compressor is replaced, so there is no moving part. The only moving part was in the vapor compression refrigeration system was the compressor, and that is replaced here. So by the pump and generator, we can say. So in the vapor absorption system, there is no moving part in the entire system. Operation is essentially quiet and subjected to very little wear. The pump motor is quite small and compared with the compressor motor. Vapor absorption system is run by the thermal energy that can be used in the places where electrical power is hard to obtain. Absorption unit can be built in the large capacity also, and space requirement is also less. So these are the different advantages of the vapor absorption refrigeration system. I would like to repeat here. Main advantage of the vapor absorption refrigeration system is the compressor is replaced. Compressor is replaced by the three components, that is absorber, pump and the generator. And here you might be having a question that pump is also moving part, but it is a very small capacity pump and very small motor is used to run the pump. So that is not having a motor which is of a same capacity of a compressor. So here we can say almost negligible. There is no moving part in a vapor absorption refrigeration system. That is the first advantage, biggest advantage. Second advantage, that it can run with the heat energy also, and that in that case exhaust steam or exhaust gases can be used to run the plant or to produce the cooling in the vapor absorption refrigeration system. Third advantage is it can be of a high capacity, and fourth is it requires the less space. So principle of vapor absorption refrigeration system is we can say what principle actually the vapor absorption refrigeration system works. So some liquid have an affinity for another substance, that it can absorb that particular substance at some pressure and temperature, and this idea of working principle working principle of the vapor absorption refrigeration system, first generated by Michael Faraday. he knew that the silver chloride, a white powder, had a property of absorbing large amount of ammonia gas at a normal temperature and pressure. So the scientists who have discovered about the vapor absorption refrigeration system was knowing for a particular gas and particular liquid that is having a affinity for that particular gas, which can be absorbed by that liquid at a particular pressure and temperature, and then at some another pressure and temperature it can be released. So that is the whole idea, or that is the working principle, we can say working principle for the vapor absorption refrigeration system. So here, which kind of other absorbent refrigerant pair can be used, that also we will see. So this is a schematic diagram of a vapor absorption refrigeration system. Very simple schematic diagram. All components are not included, but the major components are included in this. So this thing is known as thermal compressor. So here compression is taking place, but it is a very thermal compressor. It is not a mechanical compressor. So this is an absorber where the refrigerant is being absorbed by the absorbent. Then this is a generator. So from the absorber, through the liquid pump, the solution is pumped to the generator, and then at a generator it is heated, and the remaining weak solution is allowed back to the absorber. So this is absorber generator pair is known as thermal compressor, and then remaining process will be a little bit similar, that the refrigerant gas will be condensed in the condenser, then expanded in the expansion valve, and then at the low temperature refrigerant vapor will absorb the heat from the space, that is evaporator. After absorbing the heat from the evaporator, it will be evaporated, and evaporated refrigerant is again supplied to the absorber, where it will be absorbed by the absorbent solution, and then cycle is repeated. So these are the main components of a simple vapor absorption refrigeration system. So we can say absorber, generator, condenser, expansion valve and evaporator are the major component of simple vapor absorption refrigeration system. Here by the second schematic, it is actually explained that how and in which way, which are the components where the refrigerant will be heated and which are the components in which the refrigerant will be cooled. So here the familiar word, that is generator, this is the absorber, this is the condenser, and this is again the evaporator. So from this schematic you will be actually realizing which form the refrigerant will be. Suppose after the generator, refrigerant will be in a vapor form when it is heated by some driving heat source. So this is for the heat source. This is the solution initially that is heated by this heat source, and that solution, out of that solution of absorbent and refrigerant, after heating, the refrigerant will be separated and evaporated at a somewhat lower boiling point temperature, and then it is supplied to the condenser. So refrigerant vapor is condensed and converted into the liquid refrigerant, and liquid refrigerant is expanded and then supplied to the evaporator. So evaporator, in the evaporator it will absorb the heat and gets again heated, and then it is supplied to the absorber. Absorber is also, you can see that in the absorber there is a cooling water in and cooling water out circuit. So why this type of arrangement is provided in the absorber? So let me explain you that absorbent and refrigerant, they are the one liquid and gas. Now absorbent is having an affinity for the refrigerant, that it can absorb the refrigerant. So here in the absorption process of a refrigerant and absorbent, the heat is liberated. So that heat is to remove that liberated heat, the cooling water is circulated, and that keeps the absorber vessel cool. So continuously cooling water is circulated through the absorber, which will keep the absorber vessel cool so that absorption process can be enhanced. I would like to repeat here that cooling water is circulated through the absorber vessel because absorption process is exothermic. Heat is liberated during the absorption process. So if we don't remove this heat, absorption process will be slower down. So to enhance the absorption process, cooling water is circulated to remove the heat which is liberated in the absorption process. This is again a simplified diagram where the actually heat is absorbed and where the heat is rejected by the refrigerant. So heat is rejected by the refrigerant in the absorber, heat is absorbed by the refrigerant in the generator, again heat is rejected by the refrigerant in the condenser, and after expansion heat is absorbed by the refrigerant in the evaporator. So where actually the heat is absorbed and where the actually heat is rejected, that is shown in this schematic. Now we'll see the working of vapor absorption refrigeration system. So how the vapor absorption refrigeration system will work. So first you have to remember that basic absorption cycle employs two fluids. I would like to repeat here. Basic absorption cycle employs two fluids, the absorbate or refrigerant and absorbent. So we will remember that refrigerant and absorbent, two fluid system. The most commonly used fluid are water and ammonia. Ammonia is a refrigerant, and here lithium bromide and water. In that, water is used as a refrigerant and lithium bromide as a absorbent. So these fluids are separated and recombined in the absorption cycle. In the absorption cycle, the low pressure refrigerant vapor is absorbed into the absorbent, releasing large amount of heat. Liquid refrigerant absorbent solution is pumped to the high operating pressure generator using significantly less electricity than that of a compressing refrigerant in the electrical for an electric chiller. Heat is added at the high pressure generator from the gas burner, steam, hot water and hot gases, and the added heat causes the refrigerant to dissolve from the absorbent and vaporize. So let's I will repeat here. First you have to remember that the vapor absorption refrigeration system is two fluid system. First point, vapor absorption refrigeration system is two fluid system, refrigerant and absorbent. That is first thing. Second, the most commonly used fluids are ammonia and water and lithium bromide and water. Third thing is, in the absorption cycle, low pressure refrigerant vapor is absorbed by the absorbent and releasing large amount of heat. And again, the liquid refrigerant is pumped to the high operating pressure generator using very less electricity. Here in the generator, refrigerant is heated by any other source than electrical. I would like to mention here one thing, that electrical energy is the costliest form of energy. So to run the compressor in the vapor compression refrigeration system is with the electricity only. While here in the vapor absorption refrigeration system, you can use any other heat source, that is exhaust steam from the turbine, flue gases also you can use, or exhaust gases from the gas turbine, that also can be used to utilize that heat contained by them and to produce the cooling. So any other heat source, heat can be used to produce the refrigeration. Vapor flows to the condenser after heated in the generator. So any other heat source is provided in the generator that will heat the refrigerant and absorbent solution. After heating, the refrigerant gets separated in the generator. I am repeating here, refrigerant gets separated after heating from the absorbent, and heated refrigerant gas is supplied to the condenser where it is condensed. Then the condensed and rejected heat, it rejects the heat. The liquid is then throttled through the expansion valve to a lower pressure in the expansion device, and it is supplied to the evaporator. So it is throttled up to the evaporator pressure. So liquid is throttled through an expansion valve up to the lower pressure which is prevailing in the evaporator. Where it now in the evaporator it evaporates by absorbing the heat and provides the useful cooling. Remaining liquid absorbent in the generator, that means once the refrigerant is separated from the absorbent, remaining liquid absorbent is passed through the valve where its pressure is reduced, and then it is recombined with the low pressure refrigerant coming out from the evaporator, and both get mixed in the absorber. Another form of refrigeration that becomes economically attractive when the source of inexpensive heat energy at a temperature of 100 degree to 200 degree centigrade is absorption refrigeration, where the refrigerant is absorbed. So so mainly it is economically attractive. So that's why we switch on to the vapor absorption refrigeration system rather than using the vapor compression refrigeration system when there is a heat energy available at a 100 to 200 degree centigrade temperature. The most widely used vapor absorption refrigeration system is ammonia water system, where ammonia serves as a refrigerant and water as a transport medium. The work input to the pump is usually very small. So one moving part is there in the vapor absorption refrigeration system, that is very small capacity pump, but it has a very less input than the compressor. So this is a schematic for the vapor absorption refrigeration system. Here I would like to mention, this is the absorber, this is the generator where it can be run, it can use the solar energy also to heat the solution. We can have, this is one type of heat exchanger. I will explain you how it works. This is a rectifier, condenser, expansion valve, evaporator, and again back to the absorber. So now let's start from the absorber. The NH3 plus H2O, that is ammonia water solution, is pumped by the liquid pump to the generator through heat exchanger. So it is pumped to a generator. In the generator it is heated by external source of energy. Then NH3 gets separated from the H2O, and NH3 is supplied through the rectifier to the condenser. Now what is the use of rectifier? That it will separate the H2O particles from the NH3, and then NH3, pure NH3 is supplied to the condenser. So here what is the use of this? Another heat exchanger, I mean why it is supplied through the heat exchanger. So after separating out of NH3, the remaining H2O is pumped back, I mean it is supplied back to the absorber through heat exchanger. Now why to have a heat exchanger over here? Because H2O which is remaining is having a high temperature which is supplied to the absorber. In the absorber we need a little bit lower temperature. Why? Because absorption process occur at a lower temperature, not cool, but it is at a lower temperature, while the solution, strong solution which is flowing to the generator, again it is to be heated, it is going to be heated. So this solution which is coming out from the generator will give its heat to the to the solution which is going to the generator. So solution which is returning from the generator gives it heat to the solution which is going to the generator. So here because this amount of heat is rejected, it will be easier here for the to take place the absorption process. And as I have told you, absorption process is exothermic process. Heat is liberated in the absorption process, and that is we have to remove that heat by circulating the cooling water to allow or to enhance the absorption process. So here heat exchanger is provided. Rectifier function of the rectifier is to remove the water particles. Then the condensed liquid of the refrigerant is expanded through the expansion valve up to the evaporator pressure, and in the evaporator the refrigerant will absorb the heat from the space or substance to be cool and gets evaporated, and that evaporated refrigerant is supplied to the absorber. This is a vapor absorption refrigeration system. Here this is a generator. Here I would like to mention here that it is sprayed. The weak solution coming out from the generator to the absorber is sprayed so that better it can enhance the absorption process, right? And here there is a coil form of heater is shown. Again different types of schematic here I have kept so that easily you can understand in which form the refrigerant will be. So light blue color is the ammonia gas, which is from the generator to condenser. Then ammonia and water solution, that is here in the absorber, and ammonia liquid that is coming out from the condenser, that will be ammonia liquid. This is a rectifier heat exchanger. So actual ammonia water system, other than the main components of a vapor absorption refrigeration system, what are the other different components are used in the vapor absorption refrigeration system, or we can say ammonia water refrigeration system? So here you can see that there is one heat exchanger, we can say, because it is named as a preheater, but it is a heat exchanger. Then steam, exhaust steam is used for the heating purpose in a generator. Rectifier will separate the water particles, and it is a pre-cooled before it enters into the evaporator, just to increase the refrigeration effect. So this is the actual water ammonia vapor absorption refrigeration system. And this is again another schematic with all accessories. First we will see what are the different form of refrigerant. So high pressure NH3 vapor. So from where it comes? High pressure NH3 vapor. See, high pressure NH3 vapor is from the generator to the condenser, and high pressure NH3 liquid, that is coming out from the condenser, that is saturated liquid which is expanded through the expansion valve. Low pressure NH3 liquid plus vapor mixture is this, and then low pressure NH3 vapor, after absorbing the heat, the NH3 vapor that will coming out from the evaporator, and that is supplied to the absorber. This is a strong solution. By absorbing the ammonia water strong solution has this is a strong solution, that is through the pump it is supplied to the generator, where it is heated and high pressure NH3 is liberated. So weak solution is going back to the absorber. Weak solution is going back to the absorber. So these are the different where exactly in the refrigerant will be in a which form, that you can understand from this diagram, I would like to mention few things here. High pressure NH3 vapor from the generator to the condenser, strong solution in the absorber, weak solution from the generator to the absorber. So and everywhere for the cooling purpose in the absorber vessel also, as well as for in the condenser also, we are circulating the cooling water as a cooling medium. I would like to show here one video for the vapor absorption refrigeration system. Let's see the video. See here you can see the boiler, that is generator, in which the strong solution, that is ammonia water strong solution, is heated. Sometimes hydrogen gas is also used, so 3 fluid system is also used just to lower down the pressure on the system. So if that solution is heated by any other means, that can be heated by any steam or gas or whatever that thing that is in the generator, then the separated ammonia gas is supplied to the condenser. This is the condenser. Fins are provided on the tube. So here you can see that will reject the heat. Gas will reject the heat in the condenser. Then in the evaporator, in the presence of some third gas, that is like a hydrogen, it will absorb the heat at a very low pressure. It gets evaporated. So sometimes 3 fluid system can also be used in the vapor absorption refrigeration system, and that gas is not reactive with the refrigerant gas. So this kind of system can also be used as a part of vapor absorption refrigeration system. And again the refrigerant is. So now we'll see what are the desirable properties of the absorbent and refrigerant. So what are the desirable properties we'll look for? Suppose as for example, ammonia water system. So what should the ammonia have? So ammonia is highly soluble in water, that is, and the solubility of ammonia decreases as the water temperature increases. That means it can be separated if it is heated. The amount of ammonia that will go into the solution with the water decreases as the pressure decreases at a constant temperature, and the amount of ammonia that will go into the solution with the water increases as the pressure increases. That means at a high pressure more ammonia will be absorbed by the water. Weight of the solution decreases as the more ammonia is added. So these are the desirable points why ammonia and water can be used as a ideal mixture for the absorbent and refrigerant. So desirable properties of absorption system, refrigerant and absorber. So positive vapor pressure permits the boiling at a 2 degrees centigrade to minus 45 degrees centigrade, and condensation at a 40 degrees, that is higher pressure and temperature. High enthalpy of vaporization, high critical temperature and pressure, low specific heat, chemical stability, low molecular weight, high affinity for the absorber at a lower temperature, and less affinity for the later, that is generator, at a higher temperature. And for the absorber, it should have a high boiling point, low viscosity, low specific heat, chemical stability. So absorber and refrigerant combination should possess the high degree of negative deviation from the Raoult's law. Mixture should have a low specific heat and low viscosity, should give a non-corrosive mixture, and should yield a solution with as small a heat dilution as compatible with the other properties. So now we have discussed in detail about the vapor absorption refrigeration system, different components of vapor absorption refrigeration system, and how it works, how the vapor absorption refrigeration system works, and now we will see the air refrigeration system. That means how the air refrigeration system works, that is, if air is used as a refrigerant, how we can produce the cooling. So let's see about the air refrigeration system. It works on the Bell-Coleman cycle. It is having very low COP. It is bulky system and high volume flow rate. So let's see how it works. So working of air cycle refrigeration system. So air is used as a refrigerant in the air cycle refrigeration system, and main component of air refrigeration system is compressor, condenser, expander. I will not use the word condenser here, but cooler or heat exchanger. Compressor, heat exchanger, expander, and here it is not evaporated, so refrigeration system. So basically air is used as a refrigeration system. I would like to say here that air cannot change its phase from liquid to vapor and vapor to liquid. So that's why air cannot get condensed or cannot get evaporated after absorbing the heat. Air cannot change its phase. So air is easily available. Leakage will not cause any harmful effect. So these are the advantages of air cycle refrigeration system, but simultaneously it is having a low COP, and the large amount of air has to be compressed for getting a relative cooling or refrigeration effect. So here compressor, heat exchanger, expander, and refrigeration system where the heat, from where the heat is to be absorbed. So first, in the Bell-Coleman cycle, 1 to 2 isentropic compression in the compressor, then compressed air, that is high temperature, high pressure air, is supplied to the heat exchanger where 2 to 3 constant pressure cooling. So air is cooled by some other medium, say water, at a constant pressure. So 2 to 3 cooling process, constant pressure cooling process. 3 to 4 expansion in the expander, that is also isentropic expansion process, and 4 to 1 absorption of the heat in the space to be cooled. So this is a Bell-Coleman cycle. 2 isentropic processes, that is isentropic compression, constant pressure cooling, isentropic expansion, constant pressure heat absorption by the air as a refrigerant. So air refrigeration is working on Bell-Coleman cycle, and there are main 4 components: compressor, cooler, that is heat exchanger, expander, and refrigeration system. So I think you will have a good idea or better idea about the air refrigeration system, which is working on Bell-Coleman cycle, and air refrigeration system is having air as a refrigerant. So working of air refrigeration system, we have seen isentropic compression, constant pressure cooling, isentropic expansion, and constant pressure heat addition. Now we will see, so this was the about the refrigeration part, that is we were producing the cooling for the substance to be cooled or for the space to be cooled by different methods. And in that we have learned in detail about the vapor compression refrigeration system, vapor absorption refrigeration system, and air cycle refrigeration system. And now we are going to have some idea about the air conditioning. So what is that? So air conditioning is simultaneous. Let's first define the air conditioning. What is air conditioning and how it is different from the refrigeration system? So air conditioning is simultaneous control of temperature, humidity, and cleanliness of the air for either human comfort or for producing some and maintaining some environmental condition for specific industrial process. So here I would like to mention that in the air conditioning, that doesn't mean cooling. It can be cooling, but it is not only cooling. Here we are controlling the properties of air. That is, if we heat the air, that is also air conditioning for the human comfort. If we, in our country, from the 12 months, we are maintaining the lower temperature for the human comfort. That's why here we are having a concept that air conditioning, that means cooling. But it is not actually cooling. If we control the properties, that is temperature or water vapor content of the air or cleanliness, that is, if we control any of the parameters simultaneously for the human comfort, that is conditioning of the air. So air conditioning means simultaneous control of properties of the air. Now here, for producing the cooling, again we are using the small refrigeration plant, that is for producing the cooling. But I would like to mention and I would like to repeat here that air conditioning means not only cooling of air. If we heat the air and humidify the air, that is also one type of air conditioning process. If we cool the air and humidify the air in the desert cooler, that is also air conditioning process. If we cool the air and removing the or reducing the water vapor content of the air, that is also air conditioning process. So the window AC we generally use for producing the cooling, having a small refrigeration plant, that is a compressor, condenser, evaporator, condenser fan for cooling of the refrigerant. So refrigerant is there, but cool refrigerant will absorb the heat from the air, and that cool air is supplied to the room. So ultimately, with the help of a refrigerant, we have cooled the air, we have reduced the temperature of air, and that's why it is air conditioning. So by any means, we are changing the properties of the air, that means air conditioning. So this is a schematic of a window air conditioner, and here you can see the different component of a refrigeration that you have already learned. Vapor compression refrigeration system, that is compressor, condenser. For the condenser to cool the refrigerant, we are having a condenser fan, and with the cool refrigerant we are cooling the air, and cool air is supplied to the room, and for that evaporator fan. So condenser fan and evaporator fan and filters to remove the dust particle from the air. So this is the window air conditioner for cooling of air for human comfort, and that means we are reducing the temperature of air, that is by the refrigerant. So reducing the temperature of air, that's why it is air conditioning. Let's see the advantage. All of you have heard about the split air conditioner also. So what is the split air conditioner and what is the window air conditioner? So split air conditioner, in that two components are separated, that is compressor and condenser are kept somewhat away from the evaporator and expansion device. That's why it is known as split air conditioner. Advantages of split air conditioner is evaporator can be located at a convenient location. Compressor and condenser are outside the room, can be installed where the wall is exposed to the ambient is not available. So the wall which is exposed to the ambient is not available, at that place we can place the split type AC. So these are the advantages of split air conditioner, but we can have a disadvantages also. So power consumption is high, suction line needs better insulation, and there is no provision for ventilation air. These are the various disadvantages of the split air conditioner. So let me summarize the today's lecture. In today's lecture, we have discussed about the vapor absorption refrigeration system, and then some idea I have given about the air cycle refrigeration system, and then we have discussed what is actually the air conditioning, and then the comparison of window air conditioner and split air conditioner. So I hope you have better understood the topic refrigeration and air conditioning. Thank you.